Howdy math fans, it's test 15, lesson 3. Get your swords ready and let's go. So today we're going to complete the order of operations with decimals and we're going to identify factors by drawing arrays. Let's start by doing the order of operations with some decimals added in. So you're pretty familiar with the order of operations by now. You know it goes brackets first, then exponents, which you don't have in grade 6, but you should know they're there. Division and multiplication get this arrow over them because you do whichever one comes first, and the same with addition and subtraction. Whichever one comes first gets done first. So that's the order of operations, and you've been doing it all year. But now we're going to put some decimals in and see how that works. And it actually will work exactly the same way, but nonetheless, we'll look at it. So here we go. I'm going to start with the brackets, which is right here. So 1 plus 0.7, I could either do that on a calculator or I could just add it. Now remember, if you're just adding it, that you need to line up your ones and your decimals go over here. 1 is the same as 1.0. So this is going to equal 7 and 1, 1.7. So I'm going to get 1.7 times 3 equals, and I could use a calculator for this, but I'm just going to show you how to do this anyway. 1.7 times 3, 3 times 7 is 21, so I'm going to keep the 1 and carry the 2. 3 times 1 is 3, plus 2 is 5. And of course 1.7 times 3 is not going to equal 51. That doesn't make sense. I had one decimal place in my question, so I should have one decimal place in my answer. The answer is 5.1. So it works exactly the same as it would without decimals. Let's do another example here. I have 17 take away 0.5 times 4 plus 1. So no brackets, no exponents, multiplication, division. So here is my first part. I have a multiplication question. So this part will stay the same. 0.5 times 4, I'm going to do over here. Again, I could do it on a calculator, but 4 times 5 is 20. I know it's going to be 20. I'll keep the 0, carry the 2 up here. 4 times 0 is 0, plus 2 is 20. There will be one decimal spot in my answer. So it's 2.0, which is the same as 2 plus 1. Then I'm going to do my there's no more multiplication division, sorry, so I'm going to do my addition and subtraction in the order they happen. So 17 take away 2 is 15 plus 1 equals 16. And now here's one for you to try. So pause the video here and see if you can get this question. So I'm going to start with brackets. So this part will stay the same, 18 take away. 0.9 minus 0.4 is 0.5 times 0.5 equals, I don't know yet. Next up, I'm going to do the multiplication. So 0.5 times 0.5, 5 times 5 is 25. There are two decimal places in the questions, so there need to be 2 decimal places in the answer. So that's going to be 18 take away 0.25 equals, I don't know yet. And I'm just going to do that over here. 18 is the same as 18.00. Again, I could do this on a calculator. I just don't feel like it. So I'll do this the long way. 10 minus 5 is 5, 9 minus 2 is 7, the decimal drops down, 17. So the answer is 17.75. So that's it for order of operations with decimals. Works exactly the same as without decimals. Now we're going to move on and identify factors by drawing arrays. We've done a lot of factoring so far using factor rainbows. That's when you do it like this. 1 and 15, there's no 2, so we go to 3 and 5, no 4 and 6. That's a factor rainbow for 15. We're going to look at another way today, which is using arrays. So here we have, for an Earth Day project, the students in each grade have a different number of tree seedlings to plant in a park. The students are going to plant the seedlings in arrays. What number of seedlings can be planted in the greatest number of arrays? And here we have each grade and how many seedlings they're going to plant. So this is Mai, and Mai is going to sketch the possible arrays using the letter S to represent each seedlings. So she starts with grade 1. So 1 row of 18 she can do 2 rows of 9, or she can do 3 rows of 6. So the grade 1 students can plant 18 seedlings in 3 different ways. Let's find out how many arrays can be used to plant the seedlings for each of the other grades. So for grade 1 it was 3. Let's look at grade 2. So it was 25, so I can do 1 row of 25. So there's 1 row of 25. I know I can't do any rows of 2 because they won't add up evenly to 25. 3 won't work because 3 times 8 is 24. 4 won't work because 4 times 6 is 24, but I should be able to do 5s. I should be able to do 5 rows of 5. And there's all my seedlings for grade 2. So grade 2 can only do 2 different arrays. Let's go on and try grade 3. Grade 3 has 29 different seedlings. So I can do 1 row of 29, and I'm just going to switch colors for grade 3. So there's 1 row of 29. Definitely won't work with 2s because 9 is an odd number. 3s won't work because 9 times 3 is 27, and that's only 2 less. 4 won't work because 4 times 7 is 28, and that's only 1 less. 5 won't work because 5 times 6 is 30, and that already brings me up to 6. So actually, this is the only one I can do for grade 3. There's only one array that's going to work for the 29. Let's move on to grade 4. I'm just going to switch colors again. And let's see how many ways we can do 36. So obviously I can start with an array that's 1 row of 36. So there's 1 row of 36. I should be able to do 2 because 36 is even, so 2 rows of 18. So there's 2 rows of 18. 3 will work, 3 rows of 12. And I know 4 times 9 is 36, so I can definitely do 4 rows of 9. I know 5 won't work because it's a 6. 6 will work though, I can do 6 rows of 6. And since I'm doing 6 rows of 6, I won't be able to go any further. So that was pretty good. I got 1, 2, 3, 4, 5 different arrays. And I'm just going to go to a clean page for the next part. So let's move on to grade 5. Grade 5 had 48, so of course I can start by doing 1 row of 48. That's a really long one, but that's 1 row of 48. Should be able to do 2 because I've got 48's an even number, so 2 rows of 24. So there's 2 rows of 24. Not sure about 3, but I have a calculator beside me, so I'm just going to quickly check. 48 divided by 3 is 16, so I can do 3 rows of 16. So there's my 3 rows of 16. 4 should work. I should be able to do 4 rows of 12. So there's 4 rows of 12. 5 definitely won't work because it's not a 5 or a 0. 6 will because I know 6 times 8 is 48, and that's probably my last one. So I can do 6 rows of 8. So there's 6 rows of 8. So 1, 2, 3, 4, 5 different ways I can make arrays for grade 5. Now just to pause, if I wanted to write down what are the factors of 48, this first one was 1 row of 48, so it's going to be 1 and 48. The second row is 2 rows of 24, so it will be 2 and 24. This next one is 3 rows of 16, so it'll be 3 and 16. This next one is 4 rows of 12, so it'll be 4 and 12. And then I'm just going to sneak in there my last one, which was 6 rows of 8. So that would be a list of the factors. That's how you would get this out of what we're doing here. And my very last one is 56. So I can start with 1 row of 56. Wow, so there's 1 row of 56. Then I can do 2 rows of 28. There's 2 rows of 28. 3 is not going to work. 4 will work. I'm just doing it on my calculator. 56 divided by 4 is 16, so I can do 4 rows of 16. So there's 4 rows of 16. 5 will not work. 6 won't work because 6 times 10 is 60. 7 will work though. I can do 7 and 8. 7 times 8, so 7 rows of 8. So there's 7 rows of 8. So 1, 2, 3, 4 arrays for that one. So which can be the greatest number of arrays would be grades 4 and 5 tied. So drawing arrays is just another way to find factors. So here's your review for today. Number 1, use the order of operations to solve this problem. 5.2 plus 7.13 in brackets times 4 minus 3. Number 2, how do you know when to stop looking for more factors if you are using arrays, which we just did, and use an example to explain. And 3, if you're using the rainbow, how do you know when to stop looking and use an example to explain. That's it. Have a great night.